In this video, we're doing formula Riemann sums, and this time we're going to be doing a trapezoidal Riemann sum using a formula. Again, it's important to realize that you need to have equal subintervals of n to do this. The first thing I want to point out is the outside portion of the trapezoid. It says b minus a over 2n, which is different than the other ones. That's because of the formula for the area of a trapezoid. Formula for the area of a trapezoid is 1/2 base 1 plus base 2 times height. And what we've done here is we've taken the 1/2 and we've factored it out of the problem. So when I take the 1/2 and I multiply it by the b minus a over n, that gives me the b minus a over 2n. It's important to not get this confused with what you are skipping by. Skipping by is always b minus a over n, no matter what formula we use. So we've already done a left approximation and we got 40. That was an underestimate. We did a right Riemann sum approximation. We got a 56. That was an overestimate. We've done a midpoint Riemann approximation. We got 48. That was a pretty good estimate. Now we're doing a trapezoidal Riemann sum. Again, we always start with what are we trying to skip by? And that's still b minus a over n, or 9 minus 1 over 4, which is 2. If we think about it like a table, then we've got 1, 3, 5, 7, and 9. Now, when we do our Riemann sum formula, remember the outside is b minus a over 2n because we're factoring out the 1/2. So we've got 9 minus 1 over 2 times 4. Well, so that's 8 over 8, which is a 1. So we have a 1 on the outside. Now remember, with a trapezoid, we use our first value once. So we're going to plug in 1 plus 1. Now all of the middle values are going to be used twice. So when we plug in our 3, we're going to use that one twice. We're going to plug in our 5, so we're going to use that one twice. We're going to plug in our 7, that one gets used twice, and then our final value of 9 gets used once. Now, sometimes people get confused by that, but remember, it's use it once in the front, once in the back. Everything else gets used twice. Don't be alarmed that there are 5 terms for the trapezoid. That's still going to be n is 4 equal subintervals. So now if we do our calculations here, we've got 1 times 2 plus, this would be 4 times 2 is 8, plus, this would be 6 times 2 is 12, plus 8 times 2 would be 16, plus, and then we have a 10 on the end. So that's 1 times, let's see, we have 10, 20, 30, 48. So 1 times 48 is 48, and that would be our trapezoidal approximation. Frequently, the trapezoidal approximation will be the same as the midpoint approximation, but you will learn in Calculus BC that there is an error difference between the two, and it will more frequently not be equal to each other.